Hello, everyone. So we're going to talk a little bit about probability in this screencast and as it relates to genetics. So the laws of probability govern Mendelian genetics. Okay, so the laws of segregation and independent assortment are governed by rules of probability. So if you think about it, we did a little of this in class. When you toss a coin, the outcome of the toss, of one toss, has no impact on the outcome of another toss. Okay, so in the same way, the alleles of one gene segregate into gametes, and that has no effect on how another gene's alleles segregate into gametes. So again, that's independent assortment. So we're going to talk about two different rules of probability, the rule of multiplication and the rule of addition. Okay, and they can apply to monohybrid crosses as well as dihybrid crosses, trihybrid crosses, and more complex crosses. So the first rule we're going to look at is the rule of multiplication. And this states that probability that two or more independent events will occur simultaneously or to occur together is the product of their individual probabilities. Okay, so you can look at getting a certain genotype in an F1 monohybrid cross, that can be determined using the rule of multiplication. Okay, and if you look at it, so again, we're going to be here, segregation is like flipping a coin because each gamete has a 1 out of 2 chance of carrying a dominant allele and a 1 out of 2 chance of carrying a recessive allele. So if we look at this way, so if this is the genotype of my parents or the parent, okay, 1/2 the time, so the odds are 1/2 that you'll get the dominant allele, or let's say heads, and 1/2 that you'll get the recessive allele, or tails. Okay, same thing over here. 1/2 that you'll get the dominant allele, 1/2 that you get the recessive allele. If you want to look at the genotypes of the zygotes, it would be the odds of, say, this allele and this allele occurring together. So you would use the rule of multiplication. You would multiply 1/2 times 1/2 and get 1/4. So the odds that those two dominant alleles will occur together are 1/4. Okay. If you use the rule of addition, this states the probability of one of two or more exclusive events will occur is calculated by adding together the individual probabilities. Okay, so the rule of addition can be used to figure out the probability of an F2 plant from a monohybrid cross that's going to be heterozygous rather than homozygous. This also looks at the probability of two independent events occurring together. Okay, so let's look at how these rules can be used to solve more complex genetic problems. Okay, so if we're using dihybrid crosses or trihybrid crosses, doing Punnett squares with 16 squares or 32 squares or 64 squares is really not, it's very cumbersome and it's time consuming. So we can use math instead. So we can apply these rules of multiplication and addition to predict the outcome of crosses that involve multiple characters. Okay, so a dihybrid cross or other multi-character cross is the equivalent of two or more independent monohybrid crosses occurring simultaneously. Okay, so you can calculate the chances of different genotypes, and when you do this, each character is considered separately, and then the individual probabilities are multiplied. Okay, so if we look at this cross here, okay, and I want to figure out, so my question is, if we cross, if we do, this is really an F1 cross, if we cross two individuals that are heterozygous for two traits, so a dihybrid, what's the probability that I will get an offspring that has this genotype? So double homozygous dominant. So the odds that I will get this genotype from this cross, you have to look at basically these two genes individually. So first we're going to look at the probability of getting the homozygous dominant for one gene. Okay, and again, it's 1/2 odds that you're going to get that allele, 1/2 odds that you're going to get that allele. You multiply them together and you get 1/4 is the probability of getting the homozygous dominant of this. And then if you do the same thing for the other one, odds are 1/2 that you're going to get that, 1/2 that you're going to get that. So again, you multiply them together and it's 1/4 that you'll get the homozygous dominant for this. Then the odds that these two events will occur together, okay? You're going to multiply their individual probabilities. So the odds that you get these two together, you would take 1/4, multiply it by 1/4, and get 1/16. Okay? All right, and then similarly, this is, you can work on the probability of getting this genotype from that cross. Okay? And then we'll go over more of these in class. And then if we're going to look at something like this cross, okay, we have the heterozygous for 3 genes crossed with a plant that is heterozygous for 1 gene and homozygous recessive for 2 genes. Okay. Oh, excuse me. I'm so sorry. So the question is, what is the chance that we're going to get an offspring with a genotype that has at least 2 recessive traits? So it's homozygous recessive for 2 traits. Okay. So then basically you look and you write down all the possibilities. So you can get all these possibilities. This one is homozygous for homozygous recessive for those 2 traits. There's the 2 homozygous recessive there, 2 homozygous recessive there, 2 homozygous recessive there, and this one has 3 homozygous recessive, but still it has 2 homozygous recessive. Okay, so these are all the possible genotypes I can get that will answer the criteria of the question. So then what you do is you figure out what the probability is of getting each genotype, and that you use the rule of multiplication, okay? And then the probability of getting a genotype from this cross with at least 2 recessive traits. In the end, once you get the probability for each event, you're going to add them all together and figure out how often, what the probability is of getting all of these events together. Okay, and that's the rule of addition. Okay, so it's too cumbersome to go over them in the screencast, so I'm going to go over this in a little bit more detail in class. Okay, and that's it, the end. Okay, hopefully that'll give you enough of an introduction so that we can go over it a little bit more quickly in class.